So now we're going to talk about 2D kinematics. Our very first full unit was 1D kinematics, where we were talking about speed, velocity, acceleration, free fall, things like that. So now we're going to take all of those concepts and put them in 2 dimensions with projectiles. So first, I know this looks like a lot, but this is just everything that we talked about in terms of free fall in 1D projectiles. So first, dropped objects. When you drop an object, the initial velocity is 0 because you're not giving it any sort of force to get it going. So it's just going to start at 0. If you were looking for the distance that it was falling or anything like that, you would use this equation. This will be your best friend equation in this unit, trust me. So d equals v naught t plus 1/2 gt squared. And at the very bottom, your velocity at the bottom is not equal to 0. And we were talking about that's why when you fall, you get hurt. That's why you have craters. That's why you can definitely feel whenever you catch a ball, is because the velocity is not 0 at the bottom. So the other side of this is whenever you have projectiles thrown in the air, and in this instance, you have an initial velocity that is never equal to 0 because you have to throw it in some way, so it can't have 0. When the velocity is 0, then you're at the highest point in the path, so the top of the path, maximum height. And when it comes back down to the ground, the final velocity when it hits the ground is equal to the negative of the initial velocity. So if it goes up at 10 meters per second, it comes down at negative 10 meters per second. What's the same for both dropped and thrown is that gravity is always 9.8 meters per second squared. Specifically, it's going down. That's why you see g equals negative 9.8 meters per second squared. But here I didn't put the negative because I wanted to make sure you understood, again, that the negative sign means down. Both of these instances have vertical components, which means the up and down side, right? Vertical is up and down. And you use the big 4 to solve for the vertical motion. Since there is acceleration in terms of gravity, you have to use the big 4. So what is a projectile? A projectile is an object in the air under the influence of gravity only. Well, that should sound familiar. A projectile is in free fall. Okay, so we bring in 2 different vocabulary terms there. A projectile is in free fall. So a projectile can be dropped or thrown. They're both projectiles because they're both under the influence of gravity only. So consider this. At the same time a marble is launched, horizontally specifically, so launched horizontally, an identical marble is dropped from the same height. This is the demo from class. Assuming that the launched marble does not hit any obstacles, which marble will hit the ground first? So would it be the horizontally launched one or the dropped one? Well, the answer is both would hit the ground at the same time. And the reason why is because if it's launched horizontally, gravity is still affecting it exactly as if it's dropped, because that horizontal side is independent of the vertical side. So this means we must look at the vertical and horizontal independently. So the vertical does not affect the horizontal. The horizontal does not affect the vertical, which means you could launch something at whatever speed you want, and as long as it is horizontally launched, it will fall at the exact same rate and hit the ground at the exact same time as one that was just simply dropped from the same height. So a dropped object takes 5 seconds to fall. If the same object is launched horizontally at 1 meter per second, how long will it take to fall? Well, since it's launched horizontally, it takes the same amount of time. So it would still take 5 seconds. What if it was launched at 10 meters per second? Well, again, it's still launched horizontally, so the vertical is still completely unaffected. So the 10 meters per second launched projectile would also fall in 5 seconds. And going up to 100 meters per second, it would again be 5 seconds. So it does not matter what the horizontal velocity is. What matters is how high it starts. So let's look at the components. What is the only force affecting a projectile? Gravity. Gravity is the only force affecting it. So which direction does that affect? And here we need to think in terms of where the x-axis is and where the y-axis is. The x-axis is the horizontal side. The y-axis is the vertical side. So since gravity affects the vertical, gravity would affect the y-axis. Which direction has acceleration? Well, we've been talking about the acceleration due to gravity. So the side that has acceleration is, again, the y side. And which side is constant? Well, it's the side that does not have any sort of acceleration, which would be your x. X is going to be considered going at constant speed. So your horizontal speed will be constant. So the distance covered every second horizontally will be the same distance. So this is a much easier way of seeing it. So we have here a projectile that is initially launched horizontally at 5 meters per second, which means its initial velocity in the vertical is 0. After 1 second, the horizontal is still 5, but now the vertical is roughly 10. In 2 seconds, again, you should notice horizontal is the same, 5 meters per second, but now the y is increasing by 10 every second. 10, 20, 30. And at 30, it's still 5 meters per second in the horizontal. So, horizontal is constant. The velocity in the horizontal is constant. The vertical increases as you go down, and that's because what's affecting it? Gravity. And so the resultant, which is our blue arrow right here, also increases, and that's because this vertical component is increasing, so the overall resultant is increasing. So a horizontally launched projectile leaves with a velocity of 5 meters per second. So that would be the animation that we saw. What is the horizontal velocity at 1 second? Well, according to our animation, it was still 5 meters per second. What was the horizontal velocity at 5 seconds? Well, since it's constant, that means the horizontal velocity at 5 seconds would still be 5 meters per second. And so what is the horizontal velocity at any point while it's in the air? Same value. 5 meters per second. Now, what happens to the vertical velocity as it travels? Well, as time increases, the vertical velocity also increases in the downward direction. So horizontal stays constant while the vertical increases as it falls.